And a special hello to my new subscribers. Thank you for joining my channel and thank you for watching my videos. Please let me know if you need to know about a special topic in physics or mathematics or electronics. I'll be happy to make the video. Also, you can contact me via my Gmail and my Facebook, so please don't hesitate to contact me. You can also leave the comment here. I woke up at 5 o'clock today and it was so nice. I loved it because I feel at 5 o'clock, 6 o'clock, especially when the sun is rising and before the sunrise, the universe is giving you the most information. So if you want to receive those informations, you're going to be waking up at that time. So that's why I'm so happy. It's also a lot of energy in the world at that time. I woke up and I did my meditation and I did my reading, and now here I am, 10 a.m. Recording this video for you. Right, let's get to electronics. My last video was about generators and motors. If you would like to watch it, it's here. So this video I'm going to talk about the relay, and the next part of the previous video is going to be coming out soon. The reason I'm going to make the relay video right now in between is because I've made the practical part of the relay long time ago and it's been there, so I just thought today, all right, let's make the relay video and then I will make the generator video. But if you would like me to make a special video about something about motors or generators in between, let me know. Okay, what is a relay? In a really simple word, relay is a switch. But the difference between the relay and these normal switches that we're using during the day, or the push button switches, is that a relay is a magnetic switch. So it's not mechanical. You're not pushing the relay with your hand or with a mechanical devices, whereas we have a mechanical system inside. But relay becomes activated when it's connected to electricity, because there's a coil in a relay. And you know, when you connect a coil to electricity, or in other words to voltage, then the coil will become magnetized, or you can make it demagnetized. So you can make a really good electromagnet from a coil. And that's good for us because we can control it. For example, if you have a permanent magnet sitting there, it's always a magnet, right? We can't control that permanent magnet being a magnet or not being a magnet. We might be able to control it, but not as easy as a electromagnet. By the way, if you're not too sure what electromagnet is and how it works, I'm going to make a video on electromagnet soon, so you can watch that video. A relay has a coil inside, and when we connect the coil to the voltage, then the coil or the relay becomes magnetized. And when it becomes magnetized, it's working or it's acting like a permanent magnet, right? So a permanent magnet, what does it do? It attracts ferromagnets, or in other words, the metals that are good at being attracted to magnets. So it attracts magnets. So what it does, the relay is sitting there. Now a piece of metal here that is working as a connection to our circuit. So as soon as the relay becomes magnetized, then it becomes a magnet, right? So this piece of metal attracts. Now whatever the circuit is and was disconnected by this distance, now is connected. So the circuit is connected. So this is called a normally open relay, because the circuit is open, and when the relay starts working, then it becomes closed. But if the circuit is closed, and by magnetizing or demagnetizing the relay, you make the circuit open, then that's called a normally closed circuit or a normally closed relay.
Here you see a simple relay circuit. As you see, there is the coil that is connected to the voltage supply. There is the metal that is working as a switch that is connected to the light bulb. Now assume that the coil or the relay is connected to the voltage supply, or in other words, it's closed. So what will happen? The relay will become magnetized, and after that the piece of metal will be attracted, so that circuit will be closed and the light bulb will be turned on. This sort of circuit is called a normally open circuit because the circuit is open before the coil becomes magnetized. Whereas in a normally closed circuit, the relay is magnetized, and when the relay is becoming demagnetized, then the piece of metal will be going back and the light bulb will be turned off. I'm going to show you how to work with the relay. Okay, so what I have here is a DC power supply and it goes up to 30 volts. This is a relay, a 5-pin relay that I'm going to talk about its pins. And I have a light bulb here that works with around 6 volt, 7 volt. So what you see here is a 5-pin relay. Do you see the coil here? That is where the circuit gets connected and disconnected from here. And obviously this is our electromagnet, so it become magnetized and attract this bit and that attach, and it closes the circuit. And when it's demagnetized, it means that when it goes lower than the voltage that's required for magnetizing this, then that will be open, so the circuit will be open. So it's working like a magnet switch. That's why relays are also called magnetic switch. You see 87, 86 here, 87A, 30, and 85 here. We are bringing the power in, right? And it's just going to be a positive, so we are bringing the voltage in, and they are connected to the electromagnet here. So electromagnet becomes magnetized and it connects the circuit. After connecting the circuit, then we want to connect the other side of the switch, which is these two, to another circuit, whatever the circuit is. In this case, my circuit is this light bulb, so I want to turn on this light bulb. It's a simple demonstration of what is happening in the car. Positive from the power supply, as you see, and I'm going to connect it with these two coils that are bringing the power in. So 86 and 30, right? So first I'm going to connect these two together because they are both gonna get the power in, and then I will connect the red alligator clip, which is positive, to that. As you see here, I have connected 30 and 86 here, right? Now I'm going to connect this. As a positive side. We're bringing the power into the switch. Now from the switch to the rest of the circuit, whatever the circuit is. Now we want to control our circuit by this switch. So it should be series, right? So the power, DC power, is coming in to our switch and going out to this light bulb. And from the light bulb, from the negative, it's going back to our power supply. So I'm gonna put this positive, as you see, to positive side of the light bulb. Well, this light bulb doesn't have any polarity. It doesn't matter which you put where, but because this is red, so I'm just trying to respect the polarity. And then from the other side of the light bulb, we're going back to get to the negative. Of the relay is connected to the ground. So it should be connected to the ground. Right. So now I'm going to turn on the power supply, turning on the voltage. If you listen carefully, you're gonna hear the relays. Did you hear it? I'll do it again. Okay, this is the relay, and I'm turning up the voltage. Did you see that? It's 6.7. I'm going back, open, going higher, closed. Going back, open, higher, closed. Now, so I'm going a little bit further so that you can see it. So I'm going up. Now the relay is connected, but the power is just enough to just turn on the light bulb. But I'm going higher. You see the light bulb, right? Now I'm going lower. And the relay is released. Interesting, isn't it?